Good morning, students. So today we're going to discuss about the application of Gauss's theorem. So the first one is to find out the electric field for an uniformly charged infinitely long a plane sheet. Let's do it. So here there is a plane sheet which is uniformly charged and infinitely long. So I need to find out the electric field with respect to this plane sheet at any point over here or here. So since I mentioned the positive charge is over here uniformly distributed, so the direction of electric field always be outward. So for that I have considered a closed cylinder which is passing through this sheet, So, and the distance, length of this cylinder is nothing but the twicer, and this is this midpoint, and from here it is in smaller, and from here it is the distance is smaller. So I need to find out the electric field at point here. That means at a distance of smaller from with respect to this sheet. So this closed cylinder has three different parts. One is for this surface, number 1. I have mentioned the number 1. Another is this surface, mentioned in number 2, and the third one is body itself, body of the cylinder itself. This is the number 3. So in the number 1, if I consider a small section of area ds, the direction of the ds along the direction of the field. Why? Because positive charges are there, direction of the field along this way, and the ds, which is area vector of this surface, always coming out from the surface. As we already know that for the closed surface, aerial vector always coming out from the surface. Similarly, for the number 2 surface, the ds and e along the same direction. This case for the one side of the page, and this case another side of the page. And this is the body part of the cylinder. The angle between these two is 90 degree. So this is the law. E dot d is equal to q enclosed, total charge enclosed within the Gaussian surface, divided by epsilon naught. So here, since charges are uniformly distributed, so there is a concept called surface charge density. Surface charge density, and it is mentioned sigma q total divided by surface area of the cylinder. Okay, now I have divided this law into three different parts for these three different surfaces. Number 1 surface, for this number 1 surface, this is the part. For this number 2 surface, this is the part, and for this number 3 surface, the body surface, this is the part. Okay, this is equal to q by epsilon naught. Okay, so you can do in different way also, but I am doing this way. Now the angle between E dot ds for the number 1 is 0. Similarly for number 2, angle between E dot d is equal to 0. So these two become positive, 1 and 2. And the number 3, the angle between E and d is equal to 90 degree. So cos 90 is equal to 0. This is going to be 0. And this is the surface. So I have mentioned here the surface area of this section and this section is S only. Okay, since for the body part we do not require the surface area, because body part is already going to be 0, so we don't require the surface area of the body part. We need the surface of the both ends. So it's mentioned here S total surface, and I have mentioned here, I have written here the q in terms of sigma. I have written here q in terms of sigma, So Q is nothing but sigma into surface divided by epsilon naught. Okay, sigma and this get cancelled as and as. So from here you can able to write down. So this is the electrostatic field with respect to uniformly charged infinitely long plane sheet. Thank you for watching.